Welcome back to my channel. Welcome to VictorMaC. My name is Victor. Today we'll be considering sequences. Now, what's a sequence? It's a sequence of a set of terms arranged according to a prescribed rule. We have the arithmetic sequence, in which two consecutive terms differs by a common difference, and also we have the geometric sequence, also known as geometric progression, in which two consecutive terms differs by a common ratio. Now, we're going to look at this example now. So find the next two terms in each of the following set of numbers. The first one here, if you look at this first two, the difference between 4 and the previous one is 3. So the typical way of establishing common difference, or to establish whether a sequence is actually arithmetic sequence, is to study difference between two successive terms. Looking at 4 and 1, the difference is 3. Looking at 7 and 10, 10 minus 7, the difference is 3. And also looking at 10 and 13 also, this is how you establish that, okay, truly this is a common difference, and then it's called an arithmetic sequence, or you call it arithmetic progression, all right, which is shortened as AP. So we're to find the next two terms, typically just add 3 to this. We're going to have the next one will be 16, add 3 to this, the next one will be 19, all right. So, but for the second sequence, if you study it, if you add 3 to the first one, we're going to get 6, but if you add 3 to 6, we're going to get 12. So what do we notice? But if you try to divide, looking at this is first term, this is second term, this is the third, this is the fourth, and this is the fifth. When we notice that when we divide a term by the previous using this notation, if my n is 1, then I will have u2 over u1, which means second term over first term. If my n here is 2, I will have u3, because 2 plus 1, as my n, 2 plus 1 at the middle is going to have 3, and then we have u2, u4 over u3. If you study all the trend here, my second over the first, the third term over the second term, and then the fourth term over the third term, all will give us 2 over 1. That's the ratio. The ratio is common for all these two consecutive terms being divided by each other, but don't forget a term divided by the previous. 6 divided by 3, or you pick 48 divided by 24, and so on. That's the case of establishing that, okay, truly this sequence is a geometric sequence, or you call it geometric progression, which is shortened as GP. So how do we clearly differentiate AP and GP? AP and GP, how could you differentiate? When you just pick two consecutive terms, pick the first two consecutive term, test the difference, this is a term minus the previous, pick another two consecutive terms, a term minus previous, and when you compare the results, when the difference is the same, is uniform, then you know that that's a common difference, and that tells you that this sequence is an arithmetic sequence, all right. And then if that doesn't work out, if the difference doesn't work out that way, if the difference in this first one and the second one, this first pair and the second pair, is they're not uniform, then try another logic and, okay, try to divide. When we divide a pair this way, this is two consecutive terms, a term minus the previous, also a term minus the, divided by the previous, 6 over 3, and then 48 over 24. When we try to divide and we find out that the ratio we're going to get, we have them to be uniform, definitely know that this is common ratio, and that tells you that this sequence is a geometric sequence, or you call it a geometric progression. All right, now let's see how we establish this. Okay, we're to find the fourth term and seventh term of this sequence, whose nth term formula is this. Now, the terms of a sequence can be generated with this formula. And we're finding the fourth term means that just put your n, the subscript n as 4, and when we solve this, we're going to have 2 times 4 plus 1 by putting n as 4. Okay, so 8 plus 1, we're going to have 9 as the fourth term. We are looking for the seventh term. All you have to do is just to plug in your n as 7. So we have 2 times 7 plus 1 in this same formula here. That's 14 plus 1, we have 15. We can try the last two, and when we try the last two, just try on your own. You're going to get fourth term to be minus 17 when you try it out, and also for the seventh term, using this formula again also, when you try that out, you're going to get minus 32. Let's try it on your own and check your answers. All right. Now, before we wrap up, let's see this example. So find the next three terms in each of the following sets of numbers. Now, the same way, how do I know whether this sequence is an arithmetic sequence or geometric sequence? Looking at the first example here. In this case, let me try the difference. If I compare this difference, 96 minus 100. Also, let me pick another two terms, 88. Mind you, I'm using a term minus the previous. So here we have minus 4, here we have minus 4. The difference here is common, yes. Well, the common difference here is negative, and that's why we're typically having a decreasing sequence here. Our AP here is decreasing. Our arithmetic progression is decreasing in the first example because we're adding a negative number, and that's negative 4. So if I'm going to get the next three terms, I will subtract 4 from 84 here, or you use the word add minus 4. And when you say add minus 4, plus times minus gives us minus 4. Alright, so let's subtract 4 from 84, we have 80. Subtract 4 from 80, we have 76. Subtract 4 from 76, we're going to have 72. Okay, the next one, let's look at the pattern. If I should find the difference between minus 2 and 1, minus 2 minus 1. Also, let's do this, minus 8 minus 4. Difference in the first two terms and the third and fourth term is going to give us minus 3 minus 12. That shows that this is not a common difference, and this is not arithmetic progression. But I can try the other way around. Let's divide these two sets of two consecutive terms, this first two consecutive terms and this next two. Now let's divide. When we divide the second term by the first, and then the fourth term by the third, we find out that this pair we have here and this second pair that we have here be divided here is going to give us minus 2 over 1, or you call it minus 2 simple. So the ratio here is the same by dividing the second by first and by dividing the fourth by the third term. So this tells us that this second sequence is a geometric sequence. We call it geometric progression. Alright, so here we have, this is geometric progression. So how do I establish the next three terms here? Since I know that my common ratio, because common ratio has to do with GP, common ratio is minus 2, as we have obtained by dividing, and that's the case. We multiply 1 by minus 2, we get minus 2. If I multiply minus 2 by minus 2, we get 4. 4 by minus 2, we have minus 8, and so on. So let's move on to this. We multiply minus 32 by minus 2, we're going to have plus 64. Alright. Multiply 64 by minus 2, we're going to have minus 128. And we multiply minus 128 by minus 2. Please try that and let's see. I'll give you just 5 seconds. Alright, so have you tried that? Your answer will be positive 256. Okay? Alright. Thanks for watching.